So today is Monday, September 13th, 2021, and we're here with the ZVM Education Club. My name is Bill Bittner, and our speaker today is John Franciscovich, who's going to be covering a session called ZVM Startup and Shutdown Best Practices. So with that, I'll turn it over to you, John.
Thanks, Bill. Hello, everybody. Thanks for joining. Hopefully we have some good information for you today. So the name of this presentation is ZVM Startup and Shutdown Best Practices. As Bill mentioned, when we give this at events in person, it tends to be a lively discussion. Another thing I will add to that is pretty much every time we give this, somebody mentions something or we realize something in the discussion that we end up adding back into the presentation for the next time. So hopefully the presentation has grown. We've added some things that we think are useful as we go, and hopefully you'll find the same things. The other thing to be aware of is that I'm going to talk about, we're calling it best practices, some good practices, things to be aware of as you go through an IPL and a shutdown. For every specific system, the details are going to be a little different, right? Because you have different types of businesses running systems, different companies that are running our systems might have different policies and rules and things like that. And the reason, what you're using the system for, the workload you're running is going to be different. So some of the specifics that go behind some of the things I'm talking about are going to be different probably for every system that's out there. So we'll start by I'm going to talk about some things to check before you IPL. It's good to know where things are. A lot of things are set up automatically for you when the system's installed, but it's good to know where those things are because somebody will have to change those things at some point in time, or if there's maintenance done, things like that, you have to know where things are. The actual process of starting your system and IPLing your system, things to be aware of there, things that might help you out there as you go through that process. And then after IPL, making sure the resources that you think are there, that you think are supposed to be there, are actually there for the system, both from a capacity, data, networking, things like that, and then getting the various aspects of your system, the servers that are going to help your guests run, or database servers, things like that, running applications, and then the guests that are actually going to do the work. And then we'll talk about pretty much unwinding all this during shutdown, when you're shutting down your system, to get yourself to a place where when you shut down your system and you bring it back up, everything is still there and ready to use from the point it was shut down. So there's a lot of solutions out there, both from IBM and other companies, to help with managing systems, keeping up security of your system, things like that, automating various processes, various tasks that you'll do on your system. But we're the IBMers, so when we're out talking to people from other companies at different events, we talk about the IBM solutions. So here are some solutions that will help. You've seen some of these throughout some of the presentations given to the club. So RACF is our security manager. Domain is a directory manager. For automation, operations manager for ZVM is probably the most robust thing out there. There's also something called a programmable operator facility, or PROP, which will help. That's built into ZVM and it requires some programming, but you can automate some things with that. For performance monitoring, we have OmegaMon XE for ZVM and Linux. Performance Toolkit for ZVM. I know in some of the other sessions we've seen examples of some of the data that Performance Toolkit can provide and how that can be used to monitor performance, resources, different aspects of your system. And for backup and recovery, we're not going to really talk about backup and recovery today, but backup and restore manager, as well as tape manager for ZVM and Spectrum Protect. So there's a lot of tools out there, most of them are products, but essential to helping you run your system efficiently. So we'll start out by, before you start your system, things to be aware of, things to know, things you might want to set up ahead of time. So the first thing is there's a series of disks that are required to run a VM system. So you want to make sure these are all set up for you at installation time when you install VM, but you want to make sure, that you know where they are, because you will be making changes to some of these for service and things like that. Or if there's an issue, a problem of some sort, where to look for different things. So we'll start at the very beginning, which is the IPL volume. And you'll notice here I distinguish between the IPL volume and the res volume. We tend to use those names interchangeably, but they're really two different things when you're IPLing, setting up your VM system. So the IPL volume is essentially where the loader program is. So the address that you specify when you IPL, the device that you IPL is the device that contains the loader program. SAPL, standalone program loader, is the long name for that. We refer to it as SAPL, and I'll be talking about that more throughout this. The res volume is where your CP module is. So the copy of the VM control program that you're going to load into memory and actually bring up and start running ZVM. And that sits on the res volume on a CF1 PARM disk, which is owned by Maint. Also on the res volume are areas called the warm start and checkpoint areas. These are CP areas that are used to preserve data, spooling data, and some other attributes of the system. The data is saved there and preserved so it can be restored when you IPL the system. So it's saved, so when you shut down and then you re-IPL, you can bring up all the same data in the same state the system was at the time it was shut down. And the res volume also contains the object directory, which is the actual copy of the directory that the control program uses when it's running. That's what gets generated when you do a DirectXA or issue a DIRM direct commit. So that's on the res volume, the IPL and res volume. And then you see the VMCOM1 volume contains the CF0 PARM disk, and this is where the system configuration file is. And anybody who's ever IPL'd or updated a VM system has probably changed the system configuration file. So pretty much need to know where that is. So that sits on PMaint's CF0 mini disk. The other thing that's on the VMCOM1 volume is the persistent data record, or PDR. This is critical if you're running an SSI cluster. The PDR contains data about the cluster, maintains the status of the cluster and all of the member systems. So that's critical if you're going to be running an SSI cluster. And then we have other disk volumes for paging and spooling. Again, so basic setup, initial setup when you install ZVM, but you'll likely be adding paging and spooling space if you're going to be, especially if you're doing production work on a particular system, and disk volumes that contain guest and user data. So these are all things you want to be aware of. You want to know where they are. You want to know what you have defined for your system. There's a tool. So another thing that's important is your IO configuration. You want to make sure all your devices, the system has access to all of the devices that it needs and that you define for your system. And this networking, disk of storage devices, disks, all those kinds of things. So there's a tool on the main CF1 PARM disk called ESA-IO. It's the ESA-IO module, and this will help identify cabling and definition problems if there's an issue in your IO configuration. So this will validate all the paths that are defined from every device in your LPAR. It can run standalone, or it can so you can load it with the standalone loader and run it before you bring your system up, or you can try it out also on your running system. There's a chapter in the ZVM system operation manual that will give you all the details about this tool and how to run it. One thing to be aware of, so now this screenshot is right from the book. It will check everything that's defined. So you might see errors that aren't really problems, but it detects. So maybe you define a range of paths or something in your configuration, but all those paths aren't physically there or active. It will show errors as it does here for some of those. So you want to be, you need to look at this and exercise some judgment as to whether things that are detected by this ESA-IO module are really problems on your system or in your specific environment, but it can be very helpful. Okay, we have a CP system environment variable. So this will help, and especially with automation, help you identify. You can use this for several things. One of the things that people tend to like to use it for is to identify, why did I bring my system up? Am I on a production system? Is this a test environment? Am I at my disaster recovery site? Because in each of those instances, you might be IPLing the same copy of ZVM or even with the same configuration file, but you're probably going to want to do different things if you're in those different environments, especially if you're at a DR site, or maybe I just applied service and I'm just IPLing VM to make sure it IPLs but it comes up with the new service, but I'm not ready to start my workload yet. So, I want to put it kind of in a test mode. So you can use the system environment variable, cp.iplparms.iplvar. It's defined with the IPL IPL parameter. You can use that with some of your automation later on to help determine what environment am I in, and therefore what actions do I want to take that might be different from one of the other environments. So you can, set it to production, test, as you see there, or just say it's normal. I'm doing a normal startup, or I'm, doing a service startup, or whatever makes sense to you. And then, of course, you can check it manually, but be wiser to have automation. I'll mention automation a lot during this presentation. There are things that you need to do that maybe you don't need to be doing interactively all the time, but it'll be good to have data information collected and saved for various reasons. So this is an example of this environment variable will help you set up things and maybe do things as your system is running based on the environment that you're in. The standalone program loader has a menu that you can display optionally for any IPL. So the loader program is on disk. It's created during install time. There's a utility called SAPL that you can run to update the copy on disk with maybe defaults for your particular environment. But for a specific IPL, again, maybe it's a test, maybe I want to set this IPL, change the environment variable or something like that. There's a menu you can bring up that you can change the characteristics for the current IPL only. So it won't change the characteristics that are on disk. That might be your usual or standard IPL, but you can customize them for a particular IPL. So you can bring that menu up and that will help. You need to know that before you initiate the IPL, because that could affect how you do the IPL. But you have that capability to customize the loader attributes. And I'll show you an example of that a little later. If you're planning to add a new member, you're running an SSI cluster and you're planning to add a new member, you'll need to update the IO configuration. You want to add at least the channel pairs between the new LPARs and the existing LPARs that maybe you already have members running in your cluster. To add new members, you'll need to update the system configuration file. You'll have to add activate IS-link statements to define the connections for the new member. And if you're familiar with SSI, you know that you have to have direct connections defined in both directions. So direct connections from every member to every other member in both directions. So you'll have to add these activate IS-link statements from every existing member to the new member, and from the new member to every existing member. And if you're setting up a system and maybe it's going to be the first member of your cluster, but you know that you're going to be adding a second or third or maybe even fourth member in the future, the sooner you know what these configuration attributes are, the sooner you add them into both the IO configuration and your system config file, the less disruption you'll have later when you're actually bringing the member online. So you add these statements, then you activate the LPAR for the new member and IPL the new member. Once you IPL the new member to establish connectivity to the existing members that are already running, you'll need to issue activate IS-link commands on those members to establish the connection to the new member. Remember when we added them to the config file, so when the new member IPLs, it will process those statements that are in the config file, but for the running members, they won't see the config file until the next time they IPL. So you'll have to issue the commands on the running members to establish the connection to the new member so the new member can complete its IPL and the process of joining the cluster. If there's a case where you need to reinitialize your PDR, persistent data record, this is rare. Hopefully you'll never have to do this once you start your cluster, set up your cluster. But in the case where if you need to completely reinitialize the PDR, all the members of the cluster need to be down. So that's just something to be aware of. Hopefully, if you're in a cluster, you'll never have to do that. You'll need to know and want to specify the location of your system console before you IPL. So when you IPL, the system console appears where you want it to appear. It's good to know where this is in case you need to check things. So the system console can be in the operating system messages panel of the HMC. It can be on the integrated 3270 console, or it can be on any other 3270 console session that's defined. So you see on this chart, you can specify these locations, specific panels, either with a load parm at IPL time or using the cons IPL parameter. So that's how you can direct the system console or the system console to one of the panel of the HMC or the integrated 3270. And there are keywords you can put on the operator console statement in the system configuration file. Or you can just specify a device address for a place where you have a 3270 formatted session and on the operator console statement, and that will be used. The way the console statement is processed, you can specify multiple of these attributes on the operator console statement. So you could say system console, system 3270, and then have some device addresses. It will process what's specified in the order that they're specified and use the first one that it finds. So you can specify multiple addresses, and the first one that it finds is where the system console will be. And be aware that the system console is what becomes the operator console, the operator virtual machine once the operator is logged on during the system IPL. For your CP-owned volumes, you can designate ownership. So you can specify that a specific system is the owner of a module with CP space. This is handy to make sure that the correct volumes are brought online and used by and updated by the correct systems. So in a case where you have shared volumes, shared DASD across multiple LPARs, it prevents the wrong volume or the wrong system from updating a volume that might be not intentional. It might have picked it up. It might be in the CP-owned list, but you didn't really want to use it on that system. So if you're in an SSI cluster, ownership information is mandatory for CP-owned volumes. If you're not in an SSI cluster, it's optional, but it is useful. It's helpful to do. This is one of those things that I would say is a good practice or even a best practice. And you define this on CP format XA using the owner operand. You specify the system name. And if you're in a cluster, you specify the name of the SSI cluster. Otherwise, you specify no SSI. The owner and ownership information is displayed by the query CP own command in these two columns on the right. So this is an SSI cluster. So this is the name of the cluster. These are the owners, the owning members of the volume. So even though those volumes are online to this system and this member, you can see that they're actually owned by other members. So only those members can actually update. While I have access to those volumes, only the specified owners can actually update those volumes. Now you see the first one in slot 2 here, the line in yellow. This is a CP-owned volume. It's in the CP-owned list. It's brought online to my system, but there's no owner or there's no owner information defined. But I just told you it's mandatory in an SSI cluster. Well, what will happen is this volume happens to have, in addition to CP-owned areas, CP-defined areas, perm space that might have mini disks on it. So the system will detect that and will bring this volume online to my system, but only allow access to the perm space. It will not allow the system to access the CP formatted areas on the volume. And there'll be a message, you'll see a message during IPL indicating that. Another way you can verify that the correct volumes are brought online to the correct systems are by specifying the specific device address on the CP-owned statement. This is another way to verify if I happen to have multiple volumes with the same VolSeer or vol ID that a system has access to. Again, you get into this case where you're sharing disks across different LPARs and different systems. This makes sure that the system doesn't pick the volume that matches the device that I specified is the one that's brought online. So this, again, both of these can prevent issues with the wrong system writing on a volume, which would cause problems, data integrity, corrupt data, things like that. For network definitions, you can define your networks, your vSwitches, etc., in the system configuration file. If you're using inter vSwitch links or IVL type vSwitches, they need to be defined in the system configuration file. And they also must be defined and operational before you define any global vSwitches. This is a case where automation is almost mandatory. I mean, you can do it manually, but it would be a tedious process to do every time you IPL. Make sure that your IVLs are operational and their uplink ports are ready before you define any of your global switches. So in this case, you would define the IVLs in a config file, then define the other vSwitches dynamically after your system is IPL. And then, of course, you need to have those networking definitions set up before you bring on the guests that are going to be connecting to those networks. I'm advocating for automation a lot during this presentation. So where can I put all that? So there are several places. There are the Autolog1 and Autolog2 user IDs and their profiles. You can do some automation there, and I'll show you some examples of that. In individual virtual machines, so in the server virtual machine profile, you can have it checked, make sure certain resources are available that it needs to start doing its work. In the directory, you can identify command statements that will issue a CP command for a specific user as the user is logging on. So if a user has a command statement in its directory, that command statement and the command will be executed once the user is established, but before any IPL statements in that directory entry for that user are executed. So you want to make sure certain devices are attached to that user or virtual machine before the user starts IPLing, starts doing processing. You can do that with command statements. And again, I mentioned Operations Manager for ZVM. It can help in all of these phases. Once your system is up and running, can help with the automation and the sequence of events, like what I just talked about with the IVLs. It can determine the status of things and then take your next action based on that status. Think about the order you do things, and we'll talk a little bit about that. The order you do things, prerequisites, in order to start this guest, I need these these databases, these applications running. And you want to document your automation, both for your own sake, because you'll come back 6 months or a year after you establish all this, be looking at it and say, why did I do that? Why did I do that? Did I really want to mean it that way? And that also helps if you're on vacation, you're on holiday, you're on a beach, you're at a resort, and one of your colleagues has to bring up the system. That could prevent you from getting a phone call and interrupting your nice, relaxing vacation. So there's a lot of good reasons to document the processes and the automation that you set up. For the system configuration file, whenever you change it, highly recommend keeping previous versions. So before you edit and save your configuration file, copy it to a different file, a backup file. It's easier to recover. If you make a mistake or a change you make causes an issue, it's easier to revert back to the old one and then figure out what you need to change, what went wrong, things like that. And use some kind of naming convention that makes it easy to keep track of the sequence of the files, right? So there's an example here that I think some of our clients use, but whatever makes sense to you, create some kind of naming convention for your back level configuration files. For years, we preach, you always want to run CP syntax after you make a config file change. This will prevent errors. I mistype a statement, I mistype a command. CP syntax has a little bit of logic in it, checking in it, but it's not really a logic checker, but it'll make sure that in some cases, if certain statements have to be in order or something, there's a statement that follows a previous statement that defines something that a statement needs. So it'll help with that as well as, just typing errors, things like that. You want to make sure your CP syntax, the copy of CP syntax that you're using is current to your current system and service level and things like that. This way, if you make changes to your configuration file that are using something new, you'll have the latest CP syntax to verify it. You can also, in the config file, there's a tolerate config error statement that you can specify to yes or no. This will allow the system to continue IPLing even if it detects certain errors in your configuration file. There are some errors that the system can't continue with, so it will just generate a wait state or something like that. But if there are errors, you want to continue the IPL, and maybe it's something you can fix dynamically with a command later. You set it to yes, and the IPL will continue. If you set it to no, the operator will be prompted and has several options. You can stop the IPL, press ahead, or continue the IPL, but don't do any auto logs. This way you can go back and maybe a resource is missing. Maybe there's a CPO statement that's mistyped or something, and you can add that manually and then go ahead with starting your workload. So you have several degrees of protection there. Okay, so now let's talk about actually starting your system. So when you start your system, you're actually IPL the loader program or SAPL, and that goes and finds the specified CP load module, copy of ZVM that you want to run, and we'll start that and get VM executing, and then VM will do what it needs to do to initialize itself. You can also use the loader program to load and start standalone utilities. So that ESA IO tool that I mentioned, You can do standalone DDR. I think CP format XA. There's several utilities that you can run standalone before you bring your system up. And you can use the loader program to run those. Okay, so the default loader program is created when you install ZVM. There's a utility called SAPL that builds the loader program and writes it on disk. There's a menu that you can display during IPL to change any of the attributes on the written loader program. You can change for specific IPL by displaying the menu. I mentioned that. To display the menu, you specify a load parameter with the address of the System3270 console, or you can also specify sysg to display it on the integrated 3270 console. So I'm going to talk a little bit more about the loader, but there's an entire chapter in the system operations manual that goes into all the nitty-gritty details of that as well. If you opt to display the menu for a particular IPL, this is what it looks like. The fields in red here are fields that you can type over and change the values of. So the IPL device number, or the device number of the volume where your CP load module is going to be, the name of the CP load module. So this is a file on that PARM disk, and maybe I have a new one or a test module. I want to change the name. The origin, this is a field you can still type over, but you used to be able to change the origin address of your VM, the VM control program. And now, even though you can still type over that value, VM will always be loaded at address 2000. The system console address, this is that environment variable. So setting that to the IPL parameter with the environment variable to production. And this is the name, instead of the default config file name of system, I have a specific configuration file I want to use for this production system, and I'm specifying that here as well. When I have this already, I press F10 and it'll go and load. I start ZVM with these attributes. One thing you want to make you aware of, if you're migrating a ZVM system, you're running on a Z13 or earlier, and you want to migrate up to a Z15 or Z14 or an equivalent, one of the equivalent Linux One servers, to be on a Z14 or Z15, the loader program must be rewritten with at least the SAL IPL from at least 6.4, so 6.4 or later copy of SAL IPL. Otherwise, you'll not be able to IPL on one of the newer, on the Z14 or Z15. Now, why do I say ZVM 6.4? But John, ZVM 6.4 isn't even in service anymore. Well, that's true, but ZVM 6.4 was the first level of ZVM where we had support for those processors. So if the loader program was created with the SAL IPL from 6.4 or later, you'll be okay. So if you were previously running 6.4 and you updated the loader program at that point, you'll be okay. But if you hadn't, then you'll have to do that. And how this can happen is, well, when I install VM, we create the loader program. Yeah, that's true. But if you were running on a previous releases and you maybe did upgrade installations as you progress through the releases, upgrade installation does not rewrite the loader program. So if you've been using it and you have an older copy of the loader program out there, and probably in that case you haven't realized it, you'll need to run SAL IPL with one of the current releases of ZVM, more current releases of ZVM, at least 6.4. There's a red alert for this out on the web page, and the way you can tell which version of the loader program you have is in the upper right corner of the menu that I just showed you. It will show you the version, and if it says version 6 release 4 or 7.1 or 7.2, you're good. If it's anything earlier than that, you're going to need to make sure you're updated. Okay, so now we're ready to IPL. So how am I IPLing? So a lot of clients these days do their IPLs remotely. They're automated. They don't really monitor them. That's fine if you have an established system, everything's set up. It's easy to do. You can automate the type of IPL in the system configuration file on the feature statement. Most typically, you'll do an auto warm IPL, a warm start IPL. Bring up your system the way it was before, restores all the data, and especially in a production environment, that's what you're going to want to see most of the time. You can do an auto force to make sure your system comes up. But if there are any issues, there's a chance that you might lose some data if you do a force IPL and something's off a little bit, or there's something missing configuration. If you're actually doing the IPL manually and you're monitoring it on the system console, you'll get a prompt. Well, if you specify one of the auto options in the system configuration file, you won't get the prompt, even if you're monitoring the IPL. But if you don't specify those options, you'll get a prompt on the system console, and that's where you'll specify the type of IPL. The thing about the prompt also is it gives you the ability to terminate the IPL at this point. If there were messages, there were some errors in the IPL previous to this, you might want to stop and go back and fix those and then try again. So the prompt gives you the opportunity to do that. The auto IPL will give you what you ask for. Okay, so in any case, you'll want to go back and check the system and then operator's console for any messages to make sure there weren't any issues during the IPL that might affect continuing operation of your system. So as I mentioned that, so you want to watch for errors during the IPL processing. There'll also be messages if there's errors in the config file processing. If their CPL volumes are offline, you could force the system to come up, but you're likely to lose data in that case. Spool files, as well as, you may not care about the spool files as much, but your save systems and save segments, so your NSS and DCSS systems and segments could lose those as well. If there are issues with the warm start or checkpoint areas, it might prompt you and say, I can't do a warm start, but I can do a forced start. And again, it's your choice, but you need to know that if you do a forced start, the system will come up, but you might be missing some things. You might lose some of this data that I'm talking about. So when there are errors, again, it might depend if you're in a test environment. I don't really care. Just get the system up so I can run my test, or if I'm in a production environment and I might lose some data that I need to actually continue operating my system. If you get the prompt, you have the option to go either way with that. There are some errors that you will not be able to continue the IPL, and everybody who's IPL the VM system has probably at one point or another seen a wait state during IPL. So some errors, the system just can't come up and operate, so you'll get a wait state. Okay, so we've gone through the process of setting up to IPLing. Now what do I do? My system is up. Now what do I do? How do I get my workload up and running? So one thing that's good to know, and some of these things are things that you may want to, again, use automation to check, to issue some commands, store them away in a file, in a console file, so you have them for reference later. You may not need to know everything every time you IPL, but if there's an issue or you call for support, this is good information for you and or the person looking at your problem to know. So what caused this instance of the IPL? Was it a normal IPL? Did I IPL the device address? Was it a shutdown re-IPL? Did the system do a restart? And was that caused by an append? So those are all good things to know. There's a query CP load command that will give you the information about the most recent IPL. So it'll tell you what module was loaded, where it came from, as well as how the IPL was done. So was it, again, a system IPL, a shutdown? Was it a restart or something like that? Good information to collect and know after an IPL. Okay, so I'm up and running. I want to bring up my service machines, the machines that are going to assist me with operating the system. So my administrator systems management type services. So the first thing we want to bring up, no matter what, we got to get our system secured. So we want to get our security manager up and running before we start anything else. So for RACF, you would change Autolog1's profile to Autolog only RACF VM. RACF will come up. It'll start RACF. RACF will come up and initialize itself. You'll move everything else from Autolog1's profile to Autolog2. And then once RACF comes up and gets itself initialized, it will Autolog2. So all of your other startup information will get processed after the security manager is operational. So in Autolog2, you want to start your service machines for operation and monitoring. So if you're using Operations Manager or you're doing anything with prop, those are the first things you want to bring up because they can monitor and help you with the sequence of bringing up your other service machines. So they can start monitoring immediately and maybe help you with the bring up of your additional service machines and start collecting console data, verify the order of things and manage the dependencies. So again, the automation for management, the tools for that can help you actually get things done in the right order. You want to bring up your directory manager. If you're doing any monitoring, you want to start your monitor. So you start collecting data for performance. And that data also has information about system resources. So if something's missing or something like that, it can help you with that too. So monitor service, if you're running Performance Toolkit or OmegaMon, start monitoring the performance of your system as you're bringing your workload up. Your vSwitch controllers, and then your networking. You want to start TCP/IP, any other networking servers or applications that you're running. You want to have that all set up and established before you start your general workload. For the networks, I talked about the IVLs and how they need to be defined and operational before you define any of your other vSwitches on your system. So you can set up a networking script to do this in Autolog 2, where you can ping the IVL ports, and when they come back and they're, you get the right response from the ping, then you can move forward and define your additional vSwitches. So you can do this all in Autolog before you get your guests up and running. So you loop, hesitate, whatever you need to do to make sure the IVLs are all up and running, and then define your vSwitches. And again, you want those networks up before you start bringing guests up. And again, that's another strong candidate where automation is your friend. So you want to check and verify that you have the resources that you think you have or that you expect to have are available to your system. And again, once your system if it's a new system, once it's established and the configuration is right, you don't necessarily have to actively do this all the time. Plus, it's tedious. Again, you want to automate this, even if it's with just a Rex exec or a pipe or a script, to maybe issue some of these commands and save the information, save the output. You don't necessarily need to monitor it every time, but it's good information to have in case you notice something is off later or there's an issue. So you want to check the processors. You want to check that you have the amount of memory that you think you have and that it's configured as you expect it to be, your page and spool volumes, and that there's enough space. You have enough paging and spool space defined, dedicated devices for your networks that they're defined and online as well. You want to make sure you're collecting data in the event of a failure or an error. So your console files, you want to make sure the operator's console is active, as well as other key service machines. And what you want to do, the console information is written to a spool file, right? So if you just ignore it and never get those out of spool, eventually you're going to fill up your spool space. So you want to have some kind of mechanism to retrieve your console files, maybe daily, maybe every 24 hours. You close the console files, save them on a disk somewhere, retrieve them out of the spool. So you have a continuous, but it's broken up into time periods. That makes it easier if there's a problem occurred at a certain time to go back and look in that particular time frame for the data for that. You want to make sure your CP dumps are enabled, and then you have enough space for that allocated on your spool volumes. And there's documentation of how to calculate the amount of dump space you need in the CP planning and admin map. And again, you can use automation to just issue these queries, just check these things, but also something like Operation Manager, you can define thresholds. So if my paging space gets to 90% or some limit, I can do something like notify the system programmer, notify the operator, and in some cases, you can automate actions for it to take when that occurs. So that's where automation can help you, because it can be monitoring things in the background and you don't have to continuously be checking things. Once your servers are up, you'll want to start your guests. So you validate that all the servers and applications are ready, the applications running servers, your database servers, things like that. Then you'll want to start up the actual guests that are going to be running your workload. You'll want to pace that. You don't want to start all your guests at once, because there'll be a lot of contention for system resources. So you'll want to pace them, whether it's certain groups of guests or by the amount of resource they're consuming, some sensible way that makes sense for your workload to pace the order that you start up the guests, and how you identify those groups, and then verify that each group of guests is completed before starting the next group. And then doing this sequentially, you're likely to, again, depending on your workload and your resources, in a lot of cases, doing these sequentially will get everything up and running, in some cases sooner than if you try to start everything at once, because the contention will cause delays. And this pacing and verification can be anything, something very intelligent, something very sophisticated, again, using the automation tools, or it can be as simple as a script where you issue a set of commands, you sleep for a while, then issue another set of commands. So there are several degrees of sophistication you can use for this in automation. If a guest is running and you need to change something on that guest, but you don't want to disrupt the guest, you don't want to log on and stop the guest from running what it's running, there's the CP4 command, and this allows a user with the proper privileges, so a system programmer or an operator, to issue commands for that guest. The commands will actually be issued on that guest, in that guest virtual machine, but it will not disrupt what's going on in the guest. It will not interrupt the console or whatever. So the command is issued on the guest that's designated with CP4, but the response to the command is sent back to the issuer of the CP4 command. So it's a powerful way to check something going on a guest, maybe add a resource or change something about the resources on the guest without disrupting what the guest is doing. There are some things, if you change the guest's memory, the amount of memory, that will cause the guest to be restarted. But a lot of things you can do without it being disruptive to the particular guest. So I talked about different environments and different actions you might want to take and using the CP environment variables to do that. So it's good to know why you IPL'd your system. Was this a normal IPL? I'm bringing it up to, do production, in which case I want to get all the things we just talked about up and running and started. Am I doing some kind of maintenance on the system? Am I updating an application or installing a new version of a database server or something like that? In which case I might want to bring up some of my server machines, but I don't want to start my entire workload. Or am I applying service? In which case I'm going to have to do a re-IPL. I'm going to have to re-IPL my system, so there's no real point in getting all the workload up and running because I'm just going to have to maybe do another IPL. So knowing why you did it, and then you can take different actions based on that. So this is an example. This came up in one of the discussions in one of the sessions we gave, and we added into the presentation. So you can define these CP environment variables to indicate why we started the system and then determine what actions to take. To do this, we're going to use the CP system environment variable, the IPL parameter, and we're going to set up our own environment variable called current IPL var. So we have the initial one, the IPL params, and then we're going to have a current one. And we define that with the set variable system statement in the config file. And so we're going to set our current IPL variable to value of initial. And then that one we can change as we go through our processing. We can change it to allow different actions. So we can dynamically change, don't always have to do a system IPL to change the sequence that we're going to do things in. So this example, this is a snippet in the middle of a processing. So assume we've got our system up, our ESM is running, and the convention we're using is for the IPL variable, possible values are null or normal, and they represent a normal IPL. So a normal production IPL where I want to bring up all my workload. Or if we set it to no workload, that means we're doing something, some kind of service or maintenance, and we don't want to do our normal system startup. So in Autolog2's profile exec, we'll check to see if the current, this is our dynamic IPL variable that we use the set statement for. So if that has its initial value, we're going to change it according to the CP environment variable. So we'll issue the query variables command. If our current one is set to initial, then we're going to go ahead and set it. We're going to change it based on the CP environment variable. So if the CP environment variable is not equal to null, we're going to set the R variable to the current value to the variable of the initialized IPL parameter variable. If it's anything but that, we're just going to set it to normal. So if it's null, we're going to set it to normal based on the convention we defined above. The next step in Autolog2, we'll check the current value to determine what action we want to take. So we'll set our current value that we set based on the value of the IPL param. And if it's set to no workload, we're going to exit, display a message to say, okay, we IPL'd, we're doing service, so we didn't start any of our servers or guests, and we're done for now. But if we're going to be doing maintenance, we can do the maintenance, so we're going to exit this routine. We're not going to do that. But then we can do our maintenance with the set command, change the variable, change our current variable to normal. Okay, I'm done with all my maintenance. I don't need a re-IPL of my VM system. I've done what I need to do. Now we can start our guests. We can let our guests start. So we change the current variable to value normal, meaning I want to start everything up. And we go back and then we restart our Autolog2 profile exec. And then because it's normal, we're going to go through and do our normal production type startup. So this is an example using both the CP environment variable as well as the variable we define that we can change dynamically to determine what actions to take at an IPL. Another thing with 7.2, there was an APAR that was applied right after 7.2 was released. We've introduced CP function system environment variables, and these allow you to identify what function is available on my 7.2 system. And now with the new function APARs, so with new function APARs and continuous delivery, you can have multiple 7.2 systems running with different service applied. And because they have different service applied, they may or may not have different specific CP functions. So with all new function APARs now, we define a function environment variable that you can check to determine what function I actually have on this instance of my ZVM system. And then again, take action based on that. So the query variable command will show you what variables are defined. And again, that indicates what function is available. Or you can issue query variable to check for a specific function, and based on the input of that, take action. There's a web page that has a full list of the system variable names, values, and descriptions. In addition to the function variables, there are variables defined for certain of these functions that will indicate settings or limits and things like that. An example of that is with the dynamic memory configuration. There's a set of additional variables in addition to the indicator that we have that installed that indicate that some of the settings for the dynamic memory configuration. So when you go to that web page, it'll show you all of these variables and all of the values for them. Okay, shutting down is quicker. We talked a lot about IPL, getting our workload up and running. Essentially, for shutting down, you want to establish an order. Basically, it's going to be the reverse order that we brought everything up in. So you want to, shut down your guests and then shut down your servers, your database servers, and things like that. And again, you can monitor this and automate it as well. It's important to do an orderly shutdown of guests to maintain the data integrity, for the guests, any data that the guest is using or that's specific to that guest, as well as things like dirty file system for Linux, things like that. So shutting down the guests in an orderly fashion, giving them an opportunity to shut down before we essentially, without taking the VM system out from under them, is very important. Guests can enable themselves to receive a shutdown signal that when the system is shutting down or a force command is issued or a signal shutdown command, that will signal the guests that you need to shut down within a certain amount of time or by a certain specific time. That gives the guest an opportunity, that amount of time to shut down. And then when the guest completes the shutdown, it sends a signal back to VM. So VM knows each of the guests that received the signal have completed their shutdown. You define the amount of time reserved for shutdown for signal guests and for CP. You can do that in the configuration file to set the default for your system. And then you can change that with the set signal and set shutdown time commands. So shutdown time, it's in seconds, number of seconds that the system is allowed. That's for all the guests to shut down, all of your workload to shut down, as well as ZVM. So that's a signal shutdown time, that overall shutdown time that's reserved for CP to shut itself down. So in this case, guests will have 500 minus 30 seconds or 470 seconds to shut themselves down. At that point in time, if all the guests have shut down sooner, VM will proceed with its shutdown sooner than that, but that's the point in time where the VM system will shut itself down. And this is used both for CP shutdowns as well as if you deactivate the LPAR, the shutdown time will be invoked. So the signals will be sent to the guest, so we'll have an opportunity to shut down. Okay, so some of these are best practices. Some of them are good practices. They'll help you with managing the startup and shutdown of your system, making sure you have the right resources or the resources that you think you defined that you intended to have on your system are actually there and available, help things go smoothly. I mentioned at the beginning that specific steps will be different for every system based on the business that's using the system and the workload that's running on the system. I mentioned documenting things. You want to document steps, the order that you do things, when you apply automation, how your automation is set up. It'll make it easier for yourself to remember things, as well as if somebody else is doing the process. If you're, again, not available, you're off on vacation and you don't want to be interrupted, makes it easier for somebody else to do the procedures. And automate, I guess. That's the best way to do this stuff the most efficiently. Keep the data, keep the information so you can refer to it later, notify you if there is an issue, things like that. So I think of this as the know what you need, know where it is, and know the order that you need to do things. So with that, thanks for the time and thanks for listening.
Thanks, John. Have a great week, everyone.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.